Welcome to Module 5, Lesson 3, Right Triangle Trigonometry. So trigonometry has a wide array of laws, but there are some laws that are only specific to right triangles. So you've probably all heard of the acronym SOHCAHTOA, and that helps you remember the given formulas here. The sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. So let's take a look at an example. The diagram below shows right triangle UPC. Write a ratio to represent the sine of angle U. So what we're going to do is first write down the acronym SOHCAHTOA. I encourage you for any of these questions to just write down SOHCAHTOA at the top of your scrap paper so you can always reference it. Then we want to look at the angle that the question is asking about. So the question is asking about angle U, which is right here. So I like to label all the sides of the triangle in relation to angle U. So for example, side UC is the adjacent side. Side CP is the opposite side. And side UP is the hypotenuse, right? The hypotenuse is always the longest side, the side opposite of the right angle. So they want the sine of angle U. So the sine is the opposite, which is 15, over the hypotenuse, which is 17. So the sine of angle U is 15 over 17. Another type of question that you might be asked is to find the length of the side of a right triangle. So this example, they want us to find the length of side BC. So you'll use the Pythagorean theorem, which I'm sure you guys are all familiar with, which is a squared plus b squared equals c squared. Now, a and b can be either of the legs, it doesn't matter, but c is always the hypotenuse. So let's label side BC as A, side CA as B, and side BA as C. And we'll just substitute into the Pythagorean theorem. So a squared, a is what we're looking for, right? A squared plus 8 squared equals 17 squared. Then we'll simplify. A squared plus 64 equals 289. And now we'll just use inverse operations to solve for A. Subtracting 64 on both sides, we get a squared equals 225. Then we'll take the square root of both sides and we get a equals 15. So the length of side BC is 15. Please pause this video and work on the Lesson 3, Level 1 problems in the workbook. In Level 2, we're going to look at some special right triangles, and then we'll look at how to use the trig functions to solve for a side. So there are two types of special right triangles. It's the 30, 60, 90 triangle and the 45, 45, 90 triangle. And when you have right triangles with these specific angles, right, the sides of the right triangles follow these rules. So in this example, they want us to find the value of x and y. So the first thing you have to do is realize that this is a 30, 60, 90 right triangle. Now, we obviously know that this angle is 90 degrees, and we're given that this angle here is 60 degrees. So you have to realize that the missing angle is 30 degrees, because if all three angles of a triangle add up to 180, this missing angle here has to be 30. So we have a 30, 60, 90 right triangle. So now we can just follow the rules of the 30, 60, 90 right triangle. So that means this side here that's given 8, that would be our x value, right? So if we want to find this longer leg here, y, we substitute 8 for x in this x radical 3 part right here. So y would be 8 radical 3. And then this side here, the hypotenuse, it's just going to be 2x, which is 2 times 8, which is 16. So now let's look at a 45, 45, 90 triangle. Similarly to the previous question, right, they give us one angle and the right angle. And you have to realize that it's a 45, 45, 90 right triangle because all three angles of a triangle add up to 180, which means the missing angle also has to be 45 degrees. So now we'll just follow the rules of a 45, 45, 90 right triangle. We know that the two legs have the same value. So that means the value of y here has to also be 3. And the hypotenuse is x radical 2. So that means it would have to be 3 radical 2. So now let's use trigonometry to find a missing side of a right triangle. And it's very common for you to see these types of word problems that are angle of elevation problems. So as we go through these trig word problems, especially when we get to level 3, I encourage you to use the 3 reads protocol. I know we haven't used it in a while. We've done a lot of procedural work, but these types of trig problems, they have a lot of information and there's a lot of thinking and figuring out involved. So I do encourage you to use the 3 reads protocol using the template in your workbook. So a man was parasailing above a lake at an angle of elevation of 32 degrees from a boat as modeled in the diagram below. If 129.5 meters of cable connected the boat to the parasail, approximately how many meters above the lake was the man? Round your answer to the nearest tenth. So the first thing you want to do is label the side that you're looking for, right? Which is this side. The question is asking how many meters above the lake was the man, right? Here's the parasailer. So they want to know how high he was. So the length of this side here will give us that information. So you always want to label the missing side first with a variable. Now I'm going to write SOHCAHTOA on top of my scrap paper, right? Because we're going to need it and it's good to just have it handy to use. So looking at our angle of elevation here, it looks like we're looking for the opposite side and we're given the hypotenuse. So which trigonometric function deals with the opposite and the hypotenuse? That would be sine. So that means the sine of 32 degrees equals x over 129.5. And I just put the sine of 32 over 1. So that way we have a little proportion set up and we can now use cross multiplication to solve. So cross multiplying, right, we get x equals 129.5 times the sine of 32. And you can just multiply this and put this right in your calculator. And to the nearest tenth, we get x is approximately 68.6 meters. Please pause this video and work on the Lesson 3, Level 2 problems in the workbook. In Level 3, we're going to look at how to find a missing angle now. So what is the measure of angle A to the nearest degree? So we have our right triangle here, and they give us 2 sides. So looking at angle A, it looks like we have the adjacent side and the hypotenuse. So which trigonometric function deals with the adjacent side and the hypotenuse. That would be cosine. So we know that the cosine of angle A is 9/14. Okay, that's great, but how does that help us find the angle measure now? So when you have to find the angle measure, here's where you use the inverse trig functions, right? So we're going to need to use the inverse cosine to find the angle of A. So the inverse cosine of 9/14 is approximately 50 degrees. So now inverse cosine, inverse sine, inverse tangent, it looks like this, right? You have your trig function and it's raised to the negative first power. So you can do this all on the graphing calculator. Where your trig function buttons are, if you use the second function feature and you press second cosine, that will give you the inverse cosine. If you press second sine, that will give you the inverse sine. Second tangent will give you the inverse tangent, right? So you use the inverse trig function and you put the ratio of the sides that you're given, and it will give you the angle measure. Now let's take a look at a problem-solving question. This is definitely the type of question that I encourage you to use the 3 reads protocol because it's a very multi-step problem. So let's have a look. A lighthouse is built on the edge of a cliff near the ocean, as shown in the accompanying diagram. From a boat located 200 feet from the base of the cliff, the angle of elevation to the top of the cliff is 18 degrees, and the angle of elevation to the top of the lighthouse is 28 degrees. What is the height of the lighthouse X to the nearest tenth of a foot? Okay, so let's see what we know here, right? What we're given. We have 2 angles of elevation here, right? And this whole angle, 28 degrees, right? It's part of this entire right triangle. And we can use this angle to find the length of this entire side here, the cliff and the lighthouse combined. So I'm going to call that entire side X. Now, if you look at the smaller angle, the 18-degree angle, it creates this smaller right triangle, and that will help us find the length of the cliff here. I'm going to call that Y. So basically what we need to do is we need to find the value of X and we need to find the value of Y, right? The length of the entire side and the length of the cliff. And what we'll do with those 2 values is we'll subtract them and you'll be left with the length, the height of the lighthouse. So what do we have here, right? We have the opposite side, that's what we're looking for, and we're given the adjacent side here, this 200 feet. So which trigonometric function deals with the adjacent side and the opposite side? Well, that would be tangent. Tangent is opposite over adjacent. So let's find X first by taking the tangent of 28 and setting it equal to X over 200. So now we'll cross multiply to solve for X, right? X would be 200 times the tangent of 28, which is approximately 106.3. Now we need to use the tangent of 18 to solve for Y. So we'll set the tangent of 18 equal to Y over 200. We'll cross multiply and do 200 times the tangent of 18, and we get Y is approximately 65. So now we have this entire length and the length of the cliff. So what we're going to do is we'll subtract those 2 values. We'll do 106.3 minus 65, and we get 41.3. So the height of the lighthouse to the nearest tenth of a foot is 41.3 feet. Please pause this video and work on the Lesson 3, Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please move on to the next video for Lesson 4.